recently had a role change from the cloud solution architect, which Tim mentioned. And the focus today is going to be on a scenario that is very common around moving data from on-premises, perhaps, although a more general term might be cross-premises data transfer. So, so that would include, of course, the classic scenario of moving data from your on-premises environment into Azure. The target could be a variety of targets. It's not limited to any one service. We're going to do demos today that use Synapse Analytics as the target, Synapse SQL pools in particular, but that's not the only potential target. There's actually over 90 places you can move data into Azure using these techniques. And the on-premises data source could be SQL Server. Certainly, we're gonna use that as our frame of reference because this is a SQL users group, but it could also be it could be Oracle, it could be Postgres, it could be a variety of data sources that are on premises. Could also be non-relational, but we're really focusing in today's discussion around the scenario and the techniques that are related to relational database content on premises. And then to be a little more kind of generalized outside of on premises, I did say cross premises. So these techniques do also apply to maybe moving data from a virtual private cloud in AWS into Azure Data Services, or maybe even just between different parts or different deployments within Azure. So that's kind of the scenario, common scenario. It could be around app migration, could be around an analytics pipeline that maybe uploads data every night or every few hours. And we'll talk about how the services in Azure Data Factory can make that very simple, but more importantly, how you can make it perform. So I'm going to go ahead and stop my video here because I'm going into presentation mode. Can I confirm maybe that folks can see my slides?
Yes, we sure can.
Okay, great. So,
and I'll monitor for questions, Art.
That'd be great. Thank you. Thanks. So again, the title of the talk is Make Your Sure Go Burr, which is about demystifying high throughput data transfer with Azure Data Factory. We should probably start with some definition of terms for what that title means. What is a sure, right? So if you haven't worked with Azure Data Factory before, this is an acronym. It stands for Self-Hosted Integration Runtime. And it is essentially a component of Azure Data Factory. Again, Azure Data Factory is a cloud service within Azure. This is a component which enables this cross-premises data transfer scenario. So, and we're going to talk about kind of how it's set up. But it's basically a free download that you can download from downloads.microsoft.com, and you install it in a Windows VM or server on premises, and it becomes the beachhead that you can use to transfer data back and forth between Azure. We'll go into more detail on that, don't worry. But again, it's designed to facilitate like on-prem to Azure or from Azure, or from other clouds to Azure. So maybe from an AWS environment into an Azure data warehouse, for example. The little star there on Azure Data Factory is just to call out. I'm sure folks on this call, at least some of you, are familiar with Azure Synapse as well, Synapse Analytics, and that's that's the evolution of SQL Data Warehouse, as well as a number of other capabilities like Spark pools, etc. And what Microsoft and the product groups have done is actually integrated into the Synapse offering essentially the same functionality as Azure Data Factory, and that's called Synapse Pipelines when we talk about it in the context of Synapse. So I may use those terms interchangeably in this talk. They basically refer to the same thing. Azure Data Factory remains as a standalone service because there's lots of scenarios where Synapse is not part of the picture. But whenever we're working with Synapse, we typically use it as Synapse Pipelines, which is just the same functionality integrated into the Synapse portal. And in fact, the demos I do today will be using Synapse Pipelines. So that leaves another term to define, Burr. What is that, right? So that's internet slang these days. I'm sure many of you have heard it for something that's fast, right? Something that's robust, or just plain gnarly, right? Something that really gets the job done. And if we go to Urban Dictionary, their definition of Burr is to express that something is doing something, whatever it does, well, or a lot, or very quickly. can also be used to express that something is of a high quality. So if we're working for an organization and they've asked us to use this sure thing, or they've asked us to just get the job done, it's up to us to decide how to do it, and move this data, we probably want it to go Burr. We want it to be fast, right? We're probably going to have a batch window. We may have some other competing workloads that have to get done. So we want to know how to get the most out of this sure architecture. So that's the goal of today's talk, right? Is to see how we can make this cross-premises data transfer go quickly with the out-of-the-box features of Azure Data Factory and/or Synapse pipelines, using this self-hosted integration runtime. And I think what you'll see is it's surprisingly easy by adjusting some of the parameters and settings on this this capability to really ramp up the throughput and get your data moving quickly. Just a quick level set for those, this is the only kind of broad discussion we'll have around Azure Data Factory or Synapse pipelines. I assume many of the folks on the call are familiar with this, but if you're not, that's not a problem at all. You can basically, this is a service in Azure, one of the many services in Azure. This one is focused on orchestration of data movement and data transformation. You can think of it as a cloud ETL or ELT and orchestration service that can work with a wide variety of data sources as sources and sinks. It can transform data in flight, or it can just go and dispatch and sort of invoke activities that may happen in other services, like a big store procedure in SQL, or a big Hive job on a Hadoop cluster. And of course, it's designed to be able to work, as kind of this slide implies, across data sources that may be on-prem, maybe in SaaS applications, and of course that are in the public cloud, including Azure, but also other clouds. Again, we're going to focus in this talk on the very common scenario of moving relational data from one of these locations into Azure. So that's really that's as much as we're going to get in terms of broad discussion of Azure Data Factory. And in fact, we'll redraw the picture here a little bit in a way that's more specific to that scenario. So here's our kind of our starting point. We have the bubble on the left side, which is our on-premises environment, and we have the bubble on the upper right, which is Azure, where we want to move our data to. Our on-premises environment, of course, it could be a colo data center as well, is firewalled, right? It's got network security protecting the assets that are inside of it. And among those are some relational databases that we want to move. Could be SQL, could be Oracle, DB2, could be Postgres. And at the end of the day, what we want to do is be able to move the data that we need to move up into the sink or the target data stores that are up here in Azure. I mentioned earlier that Azure Data Factory supports over 90 different data sources, has connectors for over 90 different data sources. So the target here could be, we could be moving from Oracle to a SQL DB. We could be moving from SQL to a data lake to stage the data for some analytics work. We could be going from Postgres into Synapse SQL pools. The essentials of what's going to happen in between here are largely the same. So what is going to happen in between here? So I mentioned, of course, ADF as a service or Synapse pipelines is the tool that we're going to use. You can think of that as a platform as a service, self-managing thing that's in Azure, and it exposes a user interface, as you'd expect, or API calls. So you can manipulate the service through REST APIs or PowerShell commands. And that's what gives the admin or the dev, basically people on this call, the ability to configure the service and set up the things we're talking about. Now, when ADF needs to do something in the cloud, on the cloud side of this picture, it's going to use, behind the scenes, it's going to use something called the Azure Integration Runtime. You really won't get much direct interaction with the Azure Integration Runtime. Just know that that's the cloud side runtime that ADF uses to actually get work done once it's been told to do something. And that actually brings us up to the sure part of this discussion, which is how do we put a runtime on premises to be able to connect to these databases that we want to move data from. And the answer is we get a VM or a physical server on premises, and there's a free download from download.microsoft.com that you bring down and you install on this VM, and that basically registers installs a service, basically a Windows service on the VM, and it goes through a quick little handshake. There's an installer you go through. It's a very simple process. And you're basically going to kind of copy and paste a registration key from the ADF environment up here into that installer window. And that's going to allow the VM to handshake essentially and register itself with your ADF service. And now this has become kind of the orange is box here is more just the concept of the role it plays now is the self-hosted integration runtime. Now, for availability, for high availability purposes and for scalability purposes, you can actually get multiple VMs working together to do this, to play this role of the SURE. We support from 1 up to 4 VMs being working together as a single self-hosted integration runtime. And once that's set up and the SURE is registered in its companion ADF service, then you can create jobs in ADF that will pull that data from whatever whatever source relational database you're pulling from, and push it over the network out through the firewall to the Azure Integration Runtime, which will then land it in whatever target data source you're trying to move the data to. Now, there's some important security aspects to this arrow here. You note the firewall is on the picture, and one of the really nice things, it's kind of the SURE software doesn't get a lot of press for this, but it's actually able to do everything it does without any port configuration on the firewall. No inbound ports need to be opened. No VPN needs to be established between the on-prem environment and Azure. It's able to basically use a secure messaging protocol underneath. It just uses SSL basically. So it does need to have outbound 443, and that's documented in the documentation for this. But that's really all it needs to get all this work done. So as it pushes that stuff out over the network, it's going to be encrypted. There's no that's just by default. You can't turn that off. It can also be compressed to increase your throughput, depending on how much network throughput you have. It's optional, but in every case I've seen, it was definitely an advantage to compress. And again, as I mentioned, from a security perspective, no inbound ports need to be opened up, or no VPNs need to be set up on the firewall to allow this to happen. The default behavior here is that this is going to transit over the internet, and again, it will be encrypted. It's been pretty well beat up and tested and is considered secure. But if you want to, just for the record, with some additional configuration, this can be set up to go over an express route if your organization has an express route configuration between on-prem and Azure. That doesn't necessarily mean, by the way, that it's going to go faster. That really depends on what the relative network throughput is of your express route link versus the public internet, and what your company's infrastructure is like going between those environments. So that's the concept of what the SURE does in this flow and kind of how we set things up. And remember the kind of the role of this person, the administrator, to work through these user interfaces to set this stuff up. But with that said, I want to maybe actually just show you what it means to do it. So if that's what you're trying to make happen, how do you make it happen with the tool? So I'll transition to demo and we'll go to that. I'll pause and ask, is there any question? Does that all make sense? Are we kind of tracking? Sound good? And I'll take silence as a positive if there's no questions.
Right. No questions yet.
Okay, good. So given that what that slide showed about what we want to set up, this is the process you'll go through to actually do that. And you'll see it's actually very easy. Now I am assuming that I've already set up my self-hosted integration runtime. That's a very simple process. Assuming that you've got a VM, you just run this installer and it's set up and you've got it. And then it's time to get to work with the user interface. This is the Synapse Studio portal. And again, we're going to use Synapse pipelines to do this, but it's the same as ADF. So consider those as interchangeable terms. Whichever one I use here, I mean the same thing. So in order to kind of go from nothing to that picture on the diagram, I'll go here and I'll say new pipeline. I'm in the integrate hub here. And I'll create a new pipeline, and I get a blank canvas right here where I'm going to put together my control flow. I'll give this a name, the pipeline. We'll call it copy demo. And to get the work to happen here, we're going to go to our little palette here of control flow or of activities, and we'll drop this on the palette. This is our copy data activity. And what you're going to see is that.
I'm sorry, we do have a question. It might really be relevant right now. Can the self-hosted integration runtime be hosted in the cloud?
So it can, and that's how it could. There are certain scenarios where you would want to do that. For example, if you're moving from a virtual private cloud in Amazon, maybe some VMs that are running in Amazon, and you want to move that data into, let's say, Synapse, for example, or sometimes it's the appropriate thing to do in Azure. So if you've got like maybe a line of business application that's running in VMs in Azure, and it has a backend database, and all that is sort of secure in a VNet in Azure, and you need to copy data out of the data store in those VMs into whatever, right? Remember, there's 90 plus targets. There's a short list of Azure PaaS services, data services that the ADF can connect to directly without the SURE. But if you're running a VM infrastructure in Azure, you're sort of, logically speaking, you're in the same scenario, and you would need to have a SURE set up in your VNet to allow that data to be pulled out of the relational database. Does that make sense? So yes, it can, and in some cases, that's the appropriate thing, actually, depending on your configuration. So. Okay, so we're building our copy activity here. You'll find that everything that we drew on that slide before is gonna be accomplished by this one box here, this copy data activity. And to set things up, what I need to do is, I'll minimize this, use these little tabs along the bottom here to configure this task. So the first thing I want to set is the question about compression is yes. We'll see that in a minute here. So we're going to define a source for where we want this data to come from, and we do that by setting up a source data set. So I'm going to say new, and here we can see the variety of sources that I can pull data from. I'm going to filter it down to just databases, and in this case, I'm going to use a SQL server that I've got set up in a VM. And in fact, to your question, my demo was actually entirely in Azure. So my source SQL environment is in an Azure VM, and the SURE nodes are in Azure VMs as well. Again, we're talking more about a cross-premises scenario, but there are some scenarios where you would need to do it that way. So SQL Server is our source database, so we'll select that. Normally we would give this a meaningful name, and you'll see in the other demos that we do have meaningful names, but I'll just leave the default for now. And then we would select a linked service. Or we would create one. And a linked service, basically, I'm going to pick one that's already here just to keep the demo moving along. I'm going to pick our AdventureWorks linked service. And if you look at what this actually is, a bunch of SQL professionals on the call, this should look pretty familiar. This is just connection information to connect to a SQL database, right? A server name, a database name, your authentication. The important thing here, the key thing, and the linchpin piece here is this connect via integration runtime dropdown. This is where, when I set this up, the default is always the Azure integration runtime in the cloud. This is where I dropped this down and said, no, I want you to use my on-premises self-hosted integration runtime, which this is the name I gave it. And that means that this task and this source is going to be able to source data from that self-hosted integration runtime. And in particular, this connection string information is going to be resolved in the context of that runtime. So if this is a network name, that needs to be reachable by the SURE, wherever that is, to be able to actually make that connection. So I'll discard the changes because we're just going to kind of do a simple demo using what we've already got there. And then we would pick a table name. And this is actually querying through the SURE to get from the system catalog to get the tables that we want to move, or the table list to pick from. I'm going to pick fact product inventory. It doesn't matter too much which one I pick. And I'm going to say OK. And now at that point, I've identified the source for my data copy. Now I need to identify the sink, or the target of where this is going to go. To keep things quick, I'm going to move this to a target, I'm sorry, a sync data set that I've already set up, called, if I can find it, fact product inventory. And this is just basically a replica of the same table. You could tell if you've used this, you can tell from the little icon here that this is a Synapse SQL pool. This is a Synapse data warehouse. And I'm going to move this data to that as my destination. There's a variety of other options here that I'm just going to accept the defaults for. And then the last thing I'm going to do is just go over to settings. And I'm going to tell that because, with Synapse, if you've used Synapse before or SQL Data Warehouse previously, Polybase is the high performance way to load that service. And so I'm going to use the default selection here, Polybase. And to make that work, I need to come over here, check Enable Staging, and tell it a location in Data Lake Storage where it's going to stage the data files to load through Polybase. So, whoops, I don't want to do that. I'm going to go from the dropdown. I'll use my default Data Lake account. I can browse that Data Lake account right here, see the folders that are in it, and I'm going to pick sure Polybase. And at this point, the work is done essentially. This pipeline is ready to run. I can click the validate button up here to get a quick validation to run. This is the gray check mark here, tells me I'm good, and I can publish this and trigger it. I could have run it in debug mode. It's kind of 6 or 1/2 dozen of the other. And I'm going to add a trigger and say trigger now. This is basically kicking off the pipeline. Whoops, maybe I need to let it finish publishing. There we go, publishing completed. Now I can do that. So trigger now. So this is we're gonna go in and we're gonna see how this runs. And besides just showing you what happens, I'm gonna show you kind of how you would monitor these things when you're running them. And then we're going to move quickly on into, well, how do you make it go fast, right? Because that's the main point. So we'll say OK. And if we come over here, it says it's running now. We'll come over here to our monitor hub. And here in pipeline runs, we can see a list of pipelines that are running or have run. This is our one that we just created. It says it's in progress. We can go in here.
I have just a quick question. Do we have a way to do a data preview like we have in SSIS?
So yeah, there is. I kind of glossed over that part because, but yes, you can preview the data. And there's also another thing that's common in this scenario, like in SSIS, would be maybe a column mapping. Maybe I want to map columns to different columns in the target data set. Yes, that kind of stuff is supported in there. So I'm moving through a little bit quickly just to focus on the kind of the throughput and performance aspects of this. But yeah, it's a good question. And feel free to ask other questions like that. So here we're seeing basically, this is what we would see when this is in progress. At this point, this one's probably already done. But if I go here to the details, this is where I can see, what actually happened. So my data came from SQL Server. It moved as an intermediate step into some data lake storage and then was loaded into this Synapse SQL pool. I can see that it was about 32 megs of data, around 770,000 rows, and we wrote that the data in the target environment. And then some things that are interesting here from a throughput perspective are the duration of the copy, 19 seconds, and this throughput number. So this is telling us when this data was pushed, it was averaged about 1.7 megabytes per second. There's some other things in here which we'll come back to later and see kind of how different settings you make change this. But in particular, this only ran one parallel copy. It was just a simple table copy. So now if you're trying to move, let's say you're trying to move maybe 500 gigabytes of data or a terabyte of data in a nightly job or something like that, or as part of an app migration, maybe you want to move 3 or 4 terabytes of data, you'll pretty quickly find that this 1 or 3 or 4 megabyte per second throughput is not really going to get you there quickly. And that's the gist of what we're going to go through, is how you can get this to go a lot faster. Another thing that's just worth mentioning is the integration runtime itself. The Sure itself is something I can look at here in this monitor hub. I can go over here to integration runtimes and I get a list. You always have the default Azure integration runtime. That's the one that's in the cloud. And then here's the one that is my Sure that I set up, and I can click into it and see a little bit about its configuration. So you can see here that this Sure actually has 3 nodes in it. So I'm running 3 VMs, each of which I've run the little installer to have that, and I basically registered them as part of this same integration runtime. And they're sitting here ready to take work, basically, ready to be handed tasks by ADF and move the data as appropriate. You'll see over here, you can see how many jobs are currently running, which of course right now is 0. And then the number of worker tasks that the Sure has decided to set up on that node. And that's done, that's just done dynamically. When it spins up, it looks at how many cores and how much RAM are on the host machine and decides how many worker processes to spin up underneath. That's the kind of thing that you never really need to worry about, other than just maybe looking and see how much capacity that particular node has. And then once we start running things, we'll come back here and look, and you'll see concurrent jobs that are actually registered there. It's important to keep in mind that a concurrent job, this is a reference to a worker process, which can actually be multi-threaded. So an individual concurrent job there could actually be, depending on your configuration, running 4 or 5 threads of copy activity that are happening within a single job. So that's just kind of how you'll go in and look and verify, for example, that your Sure is online, and come in later and see what kind of activity it's got going on. So that kind of established, the basic concept of how do we do what was on that slide, right? So this concept of data moving from on-prem into the cloud. To do it in the simplest case of moving one table, it's just a simple case of putting this copy activity on the canvas and setting up the source and sync information. If we want this to go fast, though, of course, we might be moving a database with a lot of tables, right? So maybe there's hundreds of tables in our database. We can come in here and we can add additional copy data tasks and string them together, and they'll all run. As easily as that first one ran, you'll see that these will all run. But if our objective is throughput, this way is actually not the right way to do it. So the first thing to point out is we don't want to run these copies sequentially. Remember the picture where we had 3 or 4 VMs, and I showed you in the monitoring piece where the VMs have, in this case, 24 worker processes on them ready to do work. We don't want this to be sequential, right? We're not going to get the most out of that capacity if we do this sequentially. So the first thing I'm going to do is delete these little precedence requirements, and just, the idea here is when we run this pipeline, ADF is going to spin up these activities in parallel and run them all at the same time. And as we go through kind of the more advanced ways to configure this in the next few minutes, the common theme across all of it is going to be parallelism. So the approach and the philosophy that ADF or Synapse Pipelines is built around to get throughput is parallelism. There's some ways I'll tell you at the end about kind of just things you want to do in the hardware to get the best performance, but the big trick is parallelism as you think about how to really get maximum throughput. So this can run. We could run this, and I will go ahead and kick off a trigger. I see the question there in the window, and I'll address that actually here in a minute. Okay. I'll go ahead and kick this off, and we'll come back and look at what happens later. But that actually brings me to, so this is great. This is 3 tables, and as the question implies, what if I've got hundreds of tables? Do I have to drop 100 boxes on here or whatever? A great way to do this at scale is to you make it parameter driven. So this is another example that's essentially doing the same thing as that previous one, but we've got what's called a for each activity here in ADF. And inside the for each activity, we've just got a copy activity. And the copy activity is set up to use parameters. So this is the answer to the question there. The properties of the data set, instead of being explicitly set up in the UI here, are actually parameterized. Same thing with the sync settings. So there's actually an extensive and very nuanced set of capabilities in ADF to drive things with parameters, which is kind of outside the scope of this discussion. But that's what this uses, and that is the kind of the way you would do this at scale if you want to do this with hundreds of tables. And in fact, if we look at this, if I can, where is it? The parameters that are coming in here are are just a JSON list of table names, and they're going to be pumped in to the for basically each iteration of the for loop is going to take one of the values from JSON and execute with that as the table names for the source and the destination. So, and by default, and this, so the parallelism question, where does that fit into this picture? It's right here on this settings tab. So with the for loop activity, it defaults to be not sequential. If there's some reason you really want this to be sequential, you can check the box, but that's certainly not the way you're going to make this go fast. And then you can set the level of parallelism here with the batch count. By default, the number is 20. So if I don't put anything in here, ADF will run as many as 20 concurrent items within the for loop at any one time. And depending on how many it is, it'll, if it's hundreds, it'll just go 20 at a time. And as each one finishes, it'll get the next one. If I wanted to, I could change this. So for example, I've worked with customers where it was actually, because they were moving some extremely large tables, it actually overloaded their environment to try to do 20 at the same time. So we would neck this down to something like 5, right? And that just depends on the environment that you're in, what the infrastructure is like. So I'll go ahead and launch this so that in a minute we can go back and look at what the monitoring log for that looks like. There in the value you see, I won't dig into it, but that's actually a big JSON string that has the list of all the tables. And that's going to run, and we'll go in a minute and we'll look at what the results of that were. Just a little side note about that right there, setting up that thing. There's for future reference, it's not sort of central to this discussion today, but for future reference, there is a nice little tool here called the copy data tool, which is a wizard that builds that for loop. So if you want to just go in and point at a SQL database and just go through and check the names of all the tables you want to move and have it build the package that does that, that's what this copy data wizard does. So definitely a tool in your toolbox if you want to move a bunch of tables quickly. And in fact, I'll tell you the sort of the inside scoop on this. Like, I didn't build this myself. I used the copy data tool to build this for loop, right? And then I just tweaked a couple of things to make it part of the demo. So definitely recommend that if you want to move a bunch of tables. You can do that. So let's go over real quick and look at our monitoring for these, and then talk about a little kind of how we take the next step up from just parallelizing tables to handling like seriously big data. So let's look at our pipeline runs. We should see the two that we just ran here right now. So here's the one we ran, and we can see that, and I thought I ran this after I did that. Yeah, I guess I ran it. You know what I did? I ran it before I published. So this is a grab and show. This is the anti-pattern here, right? I ran it before I published the change to take off the sequential. And if you look at the Gantt chart, you can see that it copied each one of these tables sequentially. If I'd run it after I published, we would see that it ran these in parallel. And again, parallelism is the name of the game if you want to get throughput out of this. If we look at the for loop, hopefully I didn't mess that up, and we should see in the Gantt chart here that these things ran in parallel. So these green pipes are the duration that each table took to copy. And if you counted these, you would see that there's up to 20 that ran at one time, and then additional tables were pulled off the list to finish it up, and then it got done. So the total duration, these things all took like 20 or 30 seconds each, but the total duration of the pipeline was about 1 minute. You can see that at the bottom there. So that's parallelism across tasks, right, or across individual tables if we're kind of thinking about it in relational database terms. And that's kind of the first approach to what to do to make things go fast, or to make your data copy move quickly. And just to kind of put that in kind of visual conceptual terms, what we did here, we started out and I talked about the workers. We don't need to go into that too much. We talked about the default way, if you just string those things in a sequence, is going to be to pick up the tables. And here we're just taking a different view of the same concept. We've got our source database. It's got some tables. We've got our Azure set up on-prem. We've got the internet in between, and then ADF is receiving this stuff and putting it wherever it's supposed to go. So it's great that you can do this stuff sequentially, but you're never going to get things done quickly that way. So by enabling the parallelism of those activities in ADF, which is simple as just either use a for loop or just drop the things on the canvas and don't put lines between them, you're going to get that parallel behavior, and that stuff will move much more quickly into the sync data store. But that leaves open a question, right? So, and some of you may be thinking about this, what if you're moving your tables and you did it, multiple activities and everything's going good and you got your stuff up there, but this one table is still going, right? And it's still going. And, you come back from lunch, about 2 hours later, it's still going. Like maybe this table has 500 million rows in it, right? Maybe it has 1 billion rows in it. If you don't parallelize that, that's going to take a long time, right? And there's only so much that the Sure and having fast CPUs or fast network between these two, the source and the sink can do to make that table move quickly. And the approach, just like as I mentioned initially, the approach with ADF is to use parallelism as the way to make this scale, to make this stuff go quickly. So this is what you want to get ADF to do, is to take that big table and chunk it up and do it in parallel, right? And this is where you're going to really see it take off in terms of how quickly you can get ADF to move data. And you'll find actually that I regularly see customers do this, and maybe they're getting like 3 or 4 or 5 megabytes per second of throughput. They go in, they configure a couple of things to parallelize the individual tables, and next thing you know, they're seeing 50 or 70 or 90 megabytes per second of throughput. In some cases, this is always going to be dependent upon the specific infrastructure, like what the network configuration is like, what the VMs are like. But I've seen customers actually get well over 100 megabytes per second just by setting these things that we're going to go through here in a minute and getting ADF to do what you see here in the picture. So the question is what is the approach that ADF takes to do that, to parallelize the copy of a single table? And the concept is one that this group probably is quite familiar with. If you've done table partitioning in SQL, or if you've done partitioned views or anything like that, you're probably well familiar with the idea of horizontally partitioning a table. And ADF is designed with that in mind as the way to do this, and the way to kind of move the tables at scale. And the ways that you can partition, sort of the knobs that it exposes, or the approaches that it gives you. First off, you can use actual partitions of the table in the source database if it has them. So if your source is a SQL database and it has partitioned tables, it's as simple as you just check the box that says use table partitions, and it will query the data catalog, the metadata in SQL, find out what the partitions are, and pull the data by partition, and it'll basically spin up multiple threads, pulling the partitions in parallel, and it'll move a lot more quickly. Now you may not have that. You may not have a partition table, or you may have something that's behind a view and it can't really resolve the partitions that are behind it. Or you may even not be pulling just directly from a table. You may have a query that actually defines the source data set. Maybe it pulls a filtered list of rows from a source table, or maybe it even joins multiple tables to produce a data set that is what you're actually moving into the cloud. So that's where the dynamic range condition comes into play. And I'm going to show you this stuff in a second. So the dynamic range condition allows you to pick a column in the table, like maybe the month column or a date column or something, gives you, or even just an ID column gives you something you can use to partition the rows. And that's as simple as picking it from a dropdown. Or if you're using a query, if your data source is a query rather than just a table, there's actually a sort of a magic word you can put in your query that ADF will substitute in the necessary conditions to partition across multiple queries. And we'll show you what that looks like in a minute. And then there's also a way to do this with stored procedures and arguments that get passed into stored procedures. I'll tell you that I'm a little bit biased. I'm not a big fan of the stored procedure approach. Just the way it's implemented is kind of a little bit, it's limited. I think the first two bullets are really more effective ways to do this. So, and then once you've partitioned, then the question is, well, how much parallelism is it going to use? And you can control that, or at least influence that, with some configuration in the copy activity. There's no guarantee that the setting you put in there is actually what will happen, because ADF is going to have to make some decisions based on the actual sure configuration, how many nodes are in it, how many cores are in there, etc. But the configuration you set will at least be an upper bound for how parallel it will get. You can also just accept the auto. It will auto decide how much parallelism. My experience is that's usually too conservative. That usually won't get the maximum out of the sure environment. However, it should be said that may be what you want. We're kind of approaching this discussion from the perspective that you've got a copy, a data movement task that is basically your top priority, and you want to make it go as fast as possible, and anybody else can wait, right? You're not really worried about sharing that sure in a friendly way. But there may be a scenario where that's actually being used by many different use cases, and you might not want to saturate it by setting these things aggressively. So auto being conservative may be okay for your scenario, but if you want to make this go really fast, there's some simple configuration, and you will see it's very simple to do this. So let's switch back to demo and see what it means to do this stuff. So I'll jump out of here. We've got about 13 minutes left, so I think we're in good shape. So for example, if we did this with our little demo that we started with, our single table that was like a fact table, this started out as a non-parallel copy task. I'm going to go down into my settings here in the tabs along the bottom, and I'll go to the source. The source is the first place that I need to tell, and this is where I'm going to tell it how to partition the source table or the source query. And you'll see down here, these are the options that I showed on the slide. So if the table is partitioned, I just check that option, and it's going to dynamically use the table metadata to pull things by partition across as many parallel copies as it can. In the case, so that's real simple, but obviously that's not always. It's not, you don't always have partition tables. So dynamic range is where you can come in here, and ADF will query the columns of the table, and it's gonna filter based on the data types. It's in the documentation what the specific data types are that are allowed here, but it's basically ints and dates and date times, data types like that the engine can easily use to write a filter, like a range filter on, is what it's going to allow you to pick from here. So for example, maybe I might just use date key, and that's essentially all I have to do. Now ADF is going to go under the covers, and when it goes down to start the job pulling that table, it's going to run a query against the source table, figure out what the min and the max of that column are, and then basically divide by how many parallel copies it wants to run, and define its own ranges across that range, and spin up the copies and hand that filtered query to each copy thread, and it's going to pull up all those partitions in parallel. Does that make sense? I'll take that as a yes. So we're not really in a physical eye contact environment, but I think everybody probably gets that.
Hey, Eric, there's a couple of questions here. One is, should the source table be indexed on the partition column?
Great question. It doesn't have to be, but that is an optimization. So because of the question came in about the time I talked about how it queries. So if you index that column, it's going to be able to determine the range of data that's in it much more quickly. And in fact, that is a rule of thumb way to make that go quicker. You bet. So, and then you just, you apply whichever, balance considerations from a DBA perspective apply in your environment. As long as there's no downside to putting that index on the table in question, then yeah, go ahead and do it. So that's how we define our partitioning. I'm going to come back in a minute and show you the query variant of that, but this is how if table is the source. And then comes the hard part of how do we define the degree of parallelism, right? And I'm kind of joking when I say it's hard, because it's not hard. I just come in here to this field, degree of copy parallelism, and I put a number, like maybe 10. 10 sounds good, right? And of course, There's more smarts that you might want to put into that. Maybe I might want to go with 12. For example, if I know something about the data, if I know that column is a month column, I know there's maybe it's the number of the month, then 12 or 13 or 14 is a good number to put there. A more general rule of thumb, just to skip ahead, is the best throughput you're going to get is about 5 per node in your Sure configuration. So if your Sure has 4 nodes, which is the maximum, and you multiply by 5 per node, the top end for usually getting the most out of this is 20. So that's kind of the inside baseball on that is 20 is about the best you're going to get. And if you put it at 20, remember this is kind of established as an upper bound. ADF may make the decision to use less. So for example, in this demo, I'm going to do one with 20, but my Sure only has 3 nodes. So you'll see it only actually spins up 15 tasks, 3 times 5, right? So, but that's it. That's the whole process of configuring this to be parallel, right? And when I run this now, it's going to go a lot faster, or it would if the table was big enough to justify this. Which brings us to, I'm going to bail out of this and look at a table that does justify this, right? So I've got a table of New York City taxi data, very common demo you see these days, right? Here's the RDP session into my SQL environment. We got about 8 minutes left, so I think we're still in good shape. I'm going to target a table from this database, NYC Yellow Taxi. If we look at the tables that are in here, you see I'm going to use taxi push. This is basically taxi trip data from New York. It has 539 million rows in it. It's about 88 gigs of data. And I'll also at some point also kick off something that pulls from this worldwide importers database. We'll look at these tables as well. We're going to use the sale fact table. And that's got about 145 million rows in it. It's about 30 gigs, it looks like. Or actually, the one that we're going to pull from is a clustered column store, so it's only about 10 gigs. But so what does it mean to do that? Again, part of the point here is the configuration you have to do is about as simple as it could be. I've got a source here. I configured the source in the sink just like we showed in the earlier demo, but the dynamic range button is selected here. And I've chosen pickup month, which is a number, basically the number of the month of the pickup event, as the partition column. I've got settings of degree of parallelism is 12. And in fact, because we're getting a little short on time, I'm going to skip ahead. We would be able to see how this behaves for an individual table. But of course, to really amp things up, we want to do this with multiple tables at the same time, which of course you can do. So I'm also going to do the sales fact table. And in this case, I'm using a dynamic range. Stock item key is the column I chose, and I set the parallelism to 20. So that's going to allow it to run up as fast as we can get it to go. So I'm going to go ahead and kick this off. Say trigger now. Go ahead and let that run. It usually takes a few seconds to kind of spin up. And once this is running, what you'll see, just to kind of revisit the monitoring aspect of this, if we went in and we looked at our integration runtime, this is our 3 nodes. Right now, it hasn't actually dispatched those jobs to it. But here over the next 30 seconds or so, we'll see this come up. We'll probably see a total of about 6. It usually runs 2 worker processes per copy activity. None of that's guaranteed. And by the way, I should point out, if you see things like two worker tasks per copy activity, some of the behaviors, because ADF supports so many different sources and sinks, you may see differences in the way it handles the parallelism depending on which data sources you're using. So for example, I've done this against SQL Hyperscale, and I see slightly like it tends to, because of the way the connector works for that, it tends to parallelize a little bit less than if you're going into Synapse Analytics. It still does parallelize and it still goes fast, but it just has some slightly different behaviors. So if you see that, if you see different behaviors between different data sources, don't consider that a problem. That's just ADF kind of adapting to all the different data sources it supports. So at this point, you see we're running 6 tasks spread across these these 3 nodes. And we're now making these things do some real work. The utilization CPU is up to about 93%, 88%, 73%. And that's what you're going to see when you run these things. And you've got, I think I glossed over earlier, but there was a box for compression. I checked the box for compression, and sort of the compute resources rule of thumb for optimizing these nodes, the sure nodes, is CPU and network. Those are the resources that matter. I/O is pretty much never going to matter, and RAM is almost never going to matter. I've heard a few customers talk about RAM pressure, but rarely do we see that. It's CPU and network is what it's all about with these nodes. So if you configure this and you see yourself, you're not getting it, you've pegged your CPUs and you can't get it to go any faster. You can upsize the VMs, and you can sometimes, very often actually, get greater throughput by adding CPU capacity to the VMs. And of course, by adding, in this case, I could add a 4th VM node as well. So if we go look at the pipeline runs, we'll see the one that we kicked off is currently running. Let's go and drill into it. We see a rendition of our tasks here, and we see the 2 individual tasks down here. These little spectacles let us go in and see what's happening inside the task. And we see right now it's in progress of pulling that data from SQL Server to the data lake. And we're getting, on this task, we're getting about 30 megabytes per second of throughput. We're running 12 parallel copies because of the way we configured it, right? And on the other task, which is happening at the same time, we're getting about 63 megabytes per second on 15 parallel copies. So altogether, we're pushing about 93 megabytes per second through the Sure. And from a data perspective, you can see right now we've written, on this one, we've written 56 million rows so far in 3 minutes. So we're pushing about not quite 20 million rows per minute, which is not too bad, really. That's a pretty good rate of data copy. And at the same time, on the other table, we've pushed about 50 million rows in 3 minutes. So let's call that 15 million rows per minute. So we're moving about 30 to 35 million rows per minute between these 2 tasks. Hopefully one thing you see from that is the configuration it required me to do to go from, let's say, 1 megabyte per second to 93 megabytes per second was really quite simple, as long as you just know kind of the mindset of what ADF is expecting. Last thing, we're just about out of time, so I don't know how rigorously you guys stop it at the top of the hour, or the bottom of the hour, rather. I'll just show you. It's soft, okay. I'll just real quick show you the last part of the demo here is the dynamic query scenario. If the thing that you're pulling from is defined as a query rather than just a table, that's where you still check dynamic range here. In that case, you would have been saying you said query here instead of table, and we defined a query with whatever logic it is that we want to use to filter. In this case, the people from headquarters said only report the profitable deals. So I'm not sure if that's okay, but that's our condition. We're only pulling rows where profit is greater than 0. And then we just need to put in, I called it a magic word, but this is basically the string. And this is in the documentation. This is the string that ADF will look for to replace with its condition on this partition column. And that's how it's going to apply that partitioning. And in fact, because this is a SQL Server group, we can certainly go look at SQL Profiler and see this is, I'm not running this one, but this is, in fact, but let's make it interesting. Let's go ahead and run this one too. You can see in the ones where I didn't use a query, where I just said partition on the table and I told it to use stock item key, all the rest, this in the where clause is what ADF did for me to define the partitions. And here you can see this is the range selection that I told you about, where it's looking, and this is where, yes, you can put an index on that you can put an index on that column to make that range evaluation go more quickly. And then here, that magic word that was in the clause got in the query got substituted with range conditions on the fly to partition the data and pull it out. Does that make sense? Hopefully, yes. So
Yes.
that's a very SQL-oriented way to show you what happened under the covers, because this is a SQL users group. A couple of quick slides just to wrap things up. So we talked about this. The slides just have some screenshots of kind of the things that we looked at there. And then, I have a graph here just to give you an illustration. These are real numbers based on my test that I did for this demo, but the numbers are absolutely going to vary based on the environment you're using, right? It's going to be a function of network throughput, of the nodes, how many nodes you put in the SURE, how many cores the SURE has. So there's no hard and fast number that says this is how much faster it will get or how fast it will go, but you will see dramatic differences. Typically I see customers go from single-digit megabytes per second up into 50 to 100 megabytes per second. I worked with a customer recently who they must have had some absolutely world-class infrastructure, because they were moving data above 200 megabytes per second from their on-prem data center into Azure, just using the techniques that you saw here today. And I'll just wrap up with a couple of summaries here, maybe just to kind of pull things together, and we can certainly do questions as well. So we're just about done. Again, for the SURE itself, the VMs or the servers that host the SURE, it can be from 1 to 4 nodes that work together. The key resources are network and CPU, and maybe RAM. So just make your hardware choices with those things in mind. And you can monitor the SURE with the Azure portal, and also you can punch into the hosts that are running it, and you can watch the task manager or perfmon, whatever you like. For pipeline configuration, kind of what we walked through here was, of course, make your individual activities parallel. The for loop is a very easy way to do that. And then for large tables, the name of the game is parallelism, right? So go in there, set those little settings that I showed you. There's only a couple of them, and you can get significant increases in throughput by running those as parallel, chopping up the tables basically. And we talked about dynamic range, and another thing just to look out for is there's a setting that I kind of went through quickly in the first demo where I set staging. So basically that says ADF is going to pull the data from on-prem through the SURE, and as an intermediate step, it's going to stage it in a data lake, just Azure storage, and then push it into the final target, right? That is where most of the parallelism behaviors will get their best throughput if you do enable staging. You don't always have to. You do have to for Polybase and Synapse, but other data sources you don't have to. But generally speaking, you'll get the best parallelism behaviors if you enable staging. So that's just a kind of a tip or a recommendation there. And of course, when you're doing this, you want to maybe keep an eye on the performance characteristics of the source and the sink. Make sure you're not completely saturating your source SQL machine. That could become a limiting factor. And same thing on the sink side. So those are just some tricks. And we talked about this, just summarizes. I did want to make a comment about, and I said this a little bit in the kickoff, kind of this kinds of use cases this is good for. If you're migrating data for an app migration, if you're setting up a pipeline where maybe every night or every couple hours you're going to move data to feed an analytics workload in Azure. Those are great examples for this. For using the copy activity and using ADF. It's not always the best tool necessarily, though. So, for example, this is a SQL users group. If you're doing a direct SQL to SQL migration, where you're going from an on-prem SQL server into, and I want to be specific about this, into SQL in a VM. Now, it's not the same if you're talking about Azure SQL database. But if you're just doing like for like SQL to SQL, you're better off just using the SQL native approaches, right? So take a backup of your SQL database or set up a replication job or something like that. ADF, really, the strength of ADF is when you start talking about heterogeneous data sources and things like that. And then we also, as you probably gather from this, ADF is good and the copy activity is good for scheduled things. So if it's a one-time transfer, or if it's something where you want to schedule it to run every 20 minutes to get all the latest values and push them into the cloud, it's a great tool. If you need something that's more like reading your transaction log in real time and pushing those things into your target, which is important for some enterprise scenarios, you could maybe look at a tool like Click, which used to be called Attunity, which is oriented towards that kind of a use case. So just make sure you're kind of picking the right tool for the job. But for a very broad range of use cases, ADF copy activity is very good. So that's kind of what we wanted to show. I'm happy to take any questions. Yeah.
We have a few questions. Let's see. Talking about the machine learning portion of Synapse, does it have to have Onyx, or can it use other formats?
Sure. So that's kind of I'm happy to take that. That's obviously not the topic of the talk today.
Yeah, right.
So Synapse in general has that actually could be a 1 hour talk by itself. Machine learning in Synapse, in particular, Synapse. If you look at the overall Synapse here, and Synapse can be used to create machine learning models. It's got Spark notebooks that you can use to actually do the data science to create your machine learning models. It's got code-free. I'm getting to the Onyx question, but it's got code-free ability to do auto machine learning. So I can come in here, for example, I'm looking at it. This is a Spark database actually, and I can come here, right-click on this. If I've linked my Synapse workspace to an Azure machine learning instance, this machine learning thing will show up on the context menus, and I can actually kick off auto ML based on the data that's in that table. I won't go through that, but this whole process of actually creating the model in the first place is supported in a variety of ways with Synapse. But I think your question is pointed to, once I have a trained model and I want to use the ability inside of Synapse SQL pools in the data warehouse to basically have the model make a prediction for me as part of a select statement. There's actually a new keyword in SQL. It's specific to Synapse called predict. And I can actually select from predict, and I hand it the values that I want to predict based on, and it will actually basically call that model and add a column to my select result set that is the predicted value based on the machine learning model. So great for on-the-fly predictions in semi-real time based on an application, like what should I expect the value to be based on the things that I have in my app. And the answer to that question is Onyx, which is an acronym for a certain type of a machine learning format, a way to save a machine learning model. Currently, Onyx is the required format for that. So I hope that was not too long of an answer. You said talk about ML portion of Synapse, so I did.
That's good. That's good.
Yeah, and the answer about Onyx is yes today. And I haven't heard anything that's going to change in the near term. It may change eventually, but today Onyx is the required format.
Got it. Yeah. Let's see, what were the before and after runtimes post settings? I mean, without taking into account the sequential activity matter.
Mm-hmm. So I actually I can, if I dig in my history, that's a very good data oriented question, and if I dig in my history, I can actually pull that out and show you this here. But I can tell you in general, let's look at the last 7 days. And I can give you a general answer based on the testing here. But this is all history of those things running. And somewhere in here, I think this one is one where it didn't run parallel. So here, parallel copies is 1. And the important part of this, where it was moving data into the cloud, took 2 hours and 18 minutes. And I believe the very next one, and I have to emphasize that the impact, all these performance numbers are going to vary tremendously based on your environment, right? It's a function of the network throughput, the VMs you're using, all that stuff. So, but this is just a comparison in the environment that I used. In this case, it dropped, when I ran it with 12 parallel copies, it dropped to 50 minutes. So it went from what's 2 hours and 12 minutes, has 132 minutes down to 50 minutes. which is good. I mean,
Yeah.
you could aim for better, right? And you actually could get better. If I added a fourth sure node, for example, I could make that go faster. And there's probably some additional tweaks I could do on the, for example, it's only running 12 parallel copies. I could get that to go a little faster as well. So.
Very good. Well, see, how do we put a dynamic or put in a dynamic column to partition by if we're determining a list of tables to copy from a lookup metadata table?
That's a good question, and that is a very advanced question. Definitely not what we're going to get to today, but that goes into the parameterization of the way ADF can support parameters. And I don't have anything set up to be able to show you that, but
Gotcha.
basically, when we go through, when you click in through the interface here, if you guys can still see this, it's not always supported for every scenario. But there's this add dynamic content piece, and you can put parameter references into certain columns. And that's the short answer for how you would go about doing that. What the actual technique is beyond, I think, more than we can get to today. I don't have a demo for that. But.
Gotcha. No problem. So let's say, well, last one. What is the throughput we can get from auto resolve integration runtime?
So good question, and there is some stuff in the documentation for ADF that shows kind of what you can get for that. It will. I don't have a number at my fingertips, to be frank, but you can see it will scale itself up, or you can explicitly scale it up. There's a documentation page that we have, which I can provide the link for here in the chat in a minute, about scaling the copy activity. And it's got a grid of like source and target throughput numbers. So that'll give you an idea. But it is in the documentation in there for this DIU stands for data integration unit, roughly the kinds of throughput that you can get. I can tell you anecdotally, so this is, this may not be a satisfactory like official answer, but anecdotally, I've never seen the Azure side of it be a bottleneck, right? Usually it's the network coming out of your data center or the servers on premises. But there is documentation in there around that, the data integration units. Yeah.
All right.
Great. You're welcome, Sahidi.
A lot of thank yous in the comments, and we had a really strong attendance today. So, Art, man, thank you very much. You're welcome to come back anytime.
All right. Appreciate it. Thank you. Have fun.
Bye, everybody. Have a good weekend and good Mother's Day. We'll see you at the end of May. Thank you very much. I'm going to go ahead and stop recording.
Okay. Take care.
All right, bye-bye.